guys, Ms. Richard again. So now we're moving on to our second method of solving a system, elimination. Okay, so if you guys remember from Algebra 1 and Algebra 2, you've done this before. So this is actually example 4 in your notes. So we have our system of two equations, and they both already have the x and the y on one side and then the constant on the right. So when you're doing, when you're solving by elimination, you kind of want to think about that you're wanting to basically want to eliminate one of the variables when you add the two equations together. That's why I have them kind of stacked like so. And you have to look at your two equations and figure out what is the best way that when I do add them together, I can eliminate either x or y. And sometimes, if life is good, that's already happening. You can go ahead and add the two equations together, and one of the variables will already do that. But if you look at this example, it's not set up that way, but we can easily figure out how to do that. So when you look at the two equations, I just randomly decided that I want to eliminate y. So when I look at the two, it looks like I have positive 2y on the top and negative 3y on the bottom. So I think, okay, what can I do? I want to multiply the top equation by a number and the bottom equation by a number so I get the same constant or coefficient in front of the y. So I want to get 6y here and then negative 6y in the second equation. So to do that, I'm going to multiply the entire first equation by 3. And then the second equation, I'm going to multiply the entire equation, everything, by 2. Okay? So in doing that, when I multiply, I get 9x plus 6y equals 36. Second equation, when I multiply by 2, I get 8x minus 6y equals 66. So now, if I add my x's, add my y's, add my constants, when I do that, 6y minus 6y will actually become 0. And that's what we call elimination. I just eliminated that variable. So then I get 9x plus 8x is 17x. And then I add my constants on the right side, and 33 and 66 gives me 102. So now I only have to solve for one variable here, which makes life good. So I'm going to divide by 17 to get x by itself. And 102 divided by 17, I get x is equal to 6. A nice, pretty whole number. So now that I have solved for my variables x, to find out what y is, we're going to do just what we did with substitution and pick one of the equations, plug 6 in for x. I'm going to choose the first one to get my y value. So I'm going to plug that back in to the first equation. So I have 3 times 6 plus 2y is equal to 12. And I'm going to solve for y. So I get 18 here plus 2y equals 12. Subtract 18 from both sides, and I get 2y is equal to negative 6. Divide both sides by 2, and I get y is equal to negative 3. So I have a nice solution, only one solution this time, because they are just two lines intersecting at one spot. So it's only going to have one solution, and that solution would be 6, negative 3 for this particular example. All right, guys, look for Mr. McElhaney next. He's going to get the next 2 examples in our next video. Woo-hoo.